So I'm Josh Rubin. I'm a data scientist at Fiddler, and I guess I'm the moderator of this particular panel. So this is about using Captum and Fiddler together to improve AI model understanding. On this panel, we have the team from Facebook Captums. We have Carlos Araya, product manager of Facebook AI Applied Research, and Narina Koklikan, who's research scientist at Facebook, and they're both from the Captum team. Before meeting Narina, I know her a bit from her Captum YouTube videos, which are really excellent. And if you want to know more about Captum, I'd totally recommend going and checking those out later on. And then from the Fiddler side, we have Aalok Shanbhag, who's a senior data scientist at Fiddler. So let's spend a couple of minutes introducing ourselves. So we'll start with Narina and then go to Carlos and Aalok.
Hey, yeah, thank you for the introduction, Josh, and thank you for inviting us to this panel. I support PyTorch model understanding efforts at Facebook, and as part of those efforts, we develop tools and algorithms that facilitate machine learning model debugging, monitoring, and understanding in general. So these efforts involve both production and research-related projects, as well as internal and external collaborators.
Cool. Hi, everybody. My name's Carlos Araya, and I'm a product manager at Facebook. And I do work in the applied research group, but more specifically, I work in the AI platform team. And that team really essentially focuses on the tools and the frameworks that help our developers essentially be more productive and really build better models. One of the main areas that I support is the model understanding team that developed Captum, and Narina is the tech lead on that. And I just think this is a really interesting area to work in and a really interesting team. I think on the one hand, we see that it's a really active area of research. But at the same time, it's really trying to solve like very pragmatic and immediate problems that we see a lot of our engineers face every day. So it's really exciting to see the team really kind of take these techniques and really try to apply them to kind of Facebook problems and Facebook's scale. So anyway, I'm happy to be here, and thanks to the Fiddler team for the invitation.
Super, thanks, Carlos. Aalok?
Hi guys, I'm Aalok. I'm a data scientist here at Fiddler. And yes, apart from Fiddler is an explainable AI company, so yes, I work on explainable AI, but my core focus lately has been more on monitoring. So monitoring models that are in production. How does the data drift? If like many outliers are coming into your data stream and they are spoiling your results, data integrity, and basically anything that a model that can go wrong in a model post deployment. It's kind of my job to figure out ways and means to bring those to the notice of users.
Super. So like to kick it off, maybe Narina and Carlos, you can tell us a little bit about Captum and what it does, and maybe say something about sort of Facebook's interest in supporting explainability and what that means on your side. Sure.
Sure. So Captum is a generic and unified model interpretability library that aims to help model developers to better understand their model internals and the predictions. So we support various different types of models, including multi-model models. And that means that model inputs can be both dense and sparse features coming from various different sources. So the open source version of Captum library currently offers scalable implementations of a number of gradient and perturbation-based attribution algorithms. And we also added a couple evaluation metrics. The library is designed to be used both for research and production. We are also in the process of expanding the library to include concept-based model interpretability and adversarial robustness. And also, as I mentioned in my introduction, we have both internal users in Facebook products that use Captum, as well as external collaborators and contributors.
So in terms of kind of how we view this at Facebook and kind of why we invested in this, we both saw kind of an internal and external opportunity. And so we really started working on this about just a little under 2 years ago. And from an internal perspective, we see just a really strong need from our developers, and that's both on the product side, which are teams that are really trying to solve kind of very specific problems within products, and then also from our applied researchers that are really working on kind of new architectures and new capabilities. And what we've seen is essentially that the models have gotten more complex, but also the problem areas have gotten complex. And one of the main things that a lot of the teams really work on is content understanding. So if you think about a lot of the work that we do, it's really about trying to understand a specific like post and essentially how to classify it in some way. And so that's a very multimodal problem, right? It might have an image or video. The image might have text in it. Then the post has its own text, and there's comments, and then there's these other kinds of signals around likes and shares and things like that. And so as we try to kind of create more context or give these models more context, it's become really complex to really understand how specifically they're coming to their output. So that's one reason we really decided to invest in it. And some of the key use cases there are really around feature importance and feature selection, feature pruning. And that's really about understanding interpretability essentially at kind of the macro level, the data set level. But we also have a lot of use cases that are really much more granular about understanding interpretability at a specific sample level. And that's really more around kind of model debugging. And so we've invested quite a bit in both of those. So that's kind of the internal picture. Externally, we've seen, again, that it's essentially a really interesting kind of growth area from a research perspective. And that's both in terms of the kind of amount of research that's happening, but also how important that research is to kind of the model ecosystem as a whole. And so as part of the PyTorch ecosystem, we really wanted to engage with the community in this area and provide a library that had some of kind of the very core algorithm implementations like integrated gradients, but also essentially to create this like scaffolding and framework on which developers could easily add their algorithms and compare them easily to kind of other things that were out there. And so anyway, those were kind of the main reasons why we invested in this.
Yeah, that's a really super description. I like the multimodality. To me, I think is one of the most like exciting things about Captum. And I think from like Fiddler's perspective, when we talk to customers, a lot of the most interesting and most valuable use cases to like, you know, the organizations out there in the world of machine learning are very like, I don't know, they don't look like the simple, you know, tabular classifier examples that you see in kind of like the academic literature. It's much more like, here's a garbage can full of like text and an image and a bunch of dense features. And so, you know, having a robust framework that addresses that, I think is just super important. And I think Captum's a great model for that. So let's go to Aalok. You know, oh yeah, please.
Sorry, just as a quick note there, Josh. I mean, I think the other thing that we try to do with Captum is also Captum Insights, which is then kind of a presentation layer that's on top of it. And so that's really then about not only really understanding kind of which modalities are most important, like is the image more important than the text, but then being able to then visualize within each of those modalities what specifically is most important. So, you know, we'll put a mask on top of the image and say, well, this is the specific parts of the image that are most important, or we'll highlight specific words or tokens in the text. And so you can get kind of from a multimodal perspective, you can get a good sense of, again, which modality is contributing the most, but then within the modality, what specific parts of it are kind of most interesting. So
yeah, that's a super point. So yeah, to Aalok. So I think, you know, we think of Fiddler as this explainability monitoring platform. Can you just give us a little bit about Fiddler's mission and like why explainability is important from our perspective?
Yeah, sure. So, well, Fiddler's mission, to put it like very succinctly, is to bring trust into AI. And we believe that can only be done if it's AI is done in a responsible way, and also ensures for AI being inclusive and accountable. So a lot of big words there, but yeah, I think the gist of it, of AI being responsible, can only happen when humans are in full control of the AI. Of the AI agent. You cannot really fly blind, right? Like it's the difference between alchemy and chemistry for me. So chemistry, you know what you're doing. There are equations. There's a science behind it. Alchemy is you're just throwing things at the wall and seeing what sticks. So I think explainability is core to providing that insight and understanding of why these models are behaving as and giving these wondrous results. So yeah, I mean that's the core aspect of why Fiddler believes that explainability is central to responsible AI. Because yeah, we all know, right, that AI has this potential to transform human existence. It's a cliche, but it doesn't make it any less true. But the only way this transformation can be beneficial to like society as a whole can only be if it's used in a way that is fair, ethical, controlled. And yeah, I keep coming back to that word control. It sounds a little dystopian, but I think in this context, it's good. We need human oversight over machine learning models. They should not be running out there in the wild, and that human oversight can only happen if humans know what is happening with the model.
I like the alchemy versus chemistry comparison. So yeah, let's shift a little bit to like the place where Fiddler and Captum meet. So maybe stick with Aalok for a minute. Why don't you tell us from like the Fiddler perspective what Captum's bringing to the table for us?
Yeah, I mean, this question is easy for me to answer because you laid some groundwork for it, Josh, when you said we face all these complex models out there which are being built by our customers, and it's hard, right? Like you have experienced this, and to those who don't know, it's for complex deep models, especially, one of the core challenges to explain them is to hook into those models at the appropriate points. So that we can like properly probe their behavior, and that is easier said than done because there are a plethora of frameworks out there. There's many within those frameworks. There's a lot of flexibility, so you can build the same model in many different ways. You can use different naming conventions. So getting these hooks into the model is a complex task, and for us to be able to serve any model out there, we need a platform and a contract and an interface that is easily accessible to users and which they can make sense of. It's not feasible for us to manually sit down with every customer and help them import their model. So this interface that Captum has provided for at least for PyTorch users, they have defined and standardized that interface. And being an open source library by Facebook, we know that they will support it for a while. So that gives us the confidence of using it to extend its benefits to our own users. And again, like the thorough documentation, the tutorials, basically they are helping us serve our customers better, right? So we use Captum, we help our customers understand what we really need, and then it makes model ingestion for them a lot easier. So just to give an example, like using Captum, it can cut down like the code that the user would have to write by like more than half, I would say. I mean, I've not scientifically tested this, but it's a lot easier for our users to use Fiddler, for our PyTorch users to use Fiddler if we use Captum. So really, it was a no-brainer.
Nice. So let's and then to Narina and Carlos, can you say a little bit about what PyTorch users have to gain from in sort of production-oriented use cases, maybe things that extend beyond the data science notebook a little bit?
Yeah, so I can start telling a little bit about it. So with the growth of PyTorch community, we realized that it is essential to have tools and algorithms that can help to monitor and debug the models. So that was obvious to us. So one important thing was that those tools and techniques are solid and that they follow the same philosophy that PyTorch follows. That is, that those tools and techniques can be used both for research and production environment. So in terms of in order to make them available for production, and they have to be easy to use, they have to be solid, and they have to be generic. Apart from that, we also take into account the memory limitations and also runtime performance, so that the users, so any product that uses PyTorch can incorporate Captum into their workflows with a couple lines of code and do not worry much about how to do, for example, the distribution of computations across multiple GPUs, and how to, and whether they have to think about memory limitations or not. So those things are taken into consideration. Yeah. So Carlos.
Yeah, I guess so. So what I'll add to that is certainly when we were first developing Captum, our goals were really around helping developers build better models, and that was very much around model understanding, really in the authoring phase. So authoring, exploration, evaluation, and so what's really been great about this is that it's kind of pushed us to really think a little bit more about kind of production and inference time use cases, and also to kind of expand the set of stakeholders that we're thinking about. And we certainly see a lot of those needs, internally. Like, for example, as you guys probably know, in a lot of the areas that we work, they're generally very dynamic or kind of adversarial spaces. And so our ability to not only detect when model performance is declining in inference time, but being able to diagnose that very, very quickly, understand which specific signals are the ones that are missing. For example, there might be a new term or a new piece of slang that people are using, or people may have found a new obfuscation method with images. And so being able to detect those things very, very quickly and in figuring out how to essentially augment our data sets is something that is really critical. And then that really takes us to a lot of the monitoring use cases. And so that's both from kind of the perspective that I just said, but also because we have a relatively complex model ecosystem. So we don't have, just kind of one model that takes raw inputs. We have kind of various layers of these models that work together. And so being able to understand, large swings in attribution and how that might be a signal that some upstream model has an issue of some kind is really critical to us. And so I think, this partnership has really kind of, helped us in terms of kind of thinking in those directions.
Nice. So maybe we can talk about I don't know if there's a concrete example or two. When we've certainly written a blog post together. Aalok, do you want to mention a specific sort of Captum Fiddler integration that's notable to you?
Yeah, sure. We wrote a blog post, so we did a collaboration where we wanted to see how we can how this could be beneficial for people, like this collaboration, and we built a model, a BERT model. We fine-tuned a BERT model rather on a wiki toxicity data set, and the model was supposed to detect whether a given comment made in a wiki forum was toxic or not. And we realized that, okay, in a production, let's say you're doing this in an organization, you could use Captum, yes, and you could debug this in a notebook using the library. But if you, let's say you want to share and do further analysis, deeper analysis, as in you see, okay, these are the attributions and these are problematic. But if you want to go forward, how do you analyze that? For example, we saw that it was treating certain classes, protected classes, differently. So the word woman by itself was considered more toxic than man. And so then that's when I realized that the true power of combining the two platforms. So in Fiddler, we have this, let's say, a sort of data studio where you can analyze the data and model together, which we call Analyze. And we were able to find out, okay, what are the main reason for that is that in the data set, women appears in toxic sentences way more than it does in non-toxic as compared to men. So that ability of attributions, of having attributions, plus having a product which helps you do further debugging and analysis and query your data and model together. That's when, that was a really great example of the synergies that Fiddler and Captum bring to each other.
That's really super. Maybe we should bump on to kind of the next section, which is like, a potential of the partnership, sort of where we see, a partnership or collaboration going in the future, either in research ways or what everyone is kind of thinking about in terms of next steps. one thing that we've talked about in prior conversations is how you extend these tools into, complex machine learning ecosystems. I've already kind of brought up all of these, this sort of my experience with customer use cases that are, unusual and exotic. But it's not just the models, right? There's also these complex distributed computing infrastructure issues that you encounter when somebody shows you how their systems are working. So maybe this one's maybe for Narina and Carlos. Maybe you can talk a little bit about, complex use cases and the spectrum of, the kinds of things you encounter at Facebook and what that means in terms of research and next steps.
Yeah, sure. I mean, I think this kind of falls into two categories. So one is the complexity of the ecosystem itself, right? So there are a lot of these models, and they do interact in very complex ways. They're also being updated, and owned by different teams at kind of different cadences and things like that. And so being able to, from a model understanding perspective, being able to kind of zoom in and zoom out in terms of either looking at the entire inference graph and looking at the raw inputs and kind of what the output happens across the entire graph is important. And then being able to zoom in on specific areas is really important. And so one of the things that makes that difficult is that in certain cases, these models really can be kind of stitched together into one graph. In certain cases, some of these things are being done asynchronously, and so you can't really do that. And so that's really kind of an area of research that we're interested in. The second one that I'll mention is that, again, we deal a lot with content understanding use cases. And so really being able to understand the concepts that are being captured by models at different layers, using things like concept-based, interpretability, or really being able to, to use PCA to look at kind of what's happening at specific layers is an area that we're looking at, and Narina can say a little bit more about those.
Yeah, thank you, Carlos. Yeah, I think as Carlos mentioned, it is important to have tools to be able to both zoom in into a specific model and specific layer and deep diver to understand what's going on, and also to look at the bigger picture. So what is important is that we need tools to do both, right? We need tools to look at the whole picture and also being able to zoom in. And for that reasons, we are expanding Captum with more tools and techniques. For example, concept-based model interpretability is one research direction that we are currently looking into. This helps us to get global view of a model, like a global interpretations, as opposed to when with Lime or integrated gradients, we will have like local explanations per sample. So with a predefined set of concepts, we can actually have a global understanding of how sensitive our model, how sensitive this whole pipeline is in predicting a specific concept. And besides that, we also look into adversarial robustness and see how robust are our models to different types of perturbations. So we look into both black box and white box attacks and measure that sensitivity or vulnerability of the models to those attacks. So yeah, in general, also from research perspective, it is important to have various different tools. Have tools that will allow us to understand the feature space better, look into the feature correlations, feature interactions. So those tools have to be used all together and not, we shouldn't rely on a very specific tool and only focus on looking into a specific area. But being able to zoom in, zoom out, and keep observing and understanding, and having a human involved in the loop is also very important in those cases.
Yeah, that's a super answer. I'm going to just take us off the rails for a second because we have a question that's just like bang on this subject. So Bashar Hassan asks, can Captum handle explanation in hierarchical models scenario or in pipeline models? And then how do you handle contradictory evidence interpretation between the different models in the pipeline? So this may be, already sort of addressed by this kind of zooming in and out that you've described. But I think there's kind of two questions there. One is about ensemble sort of composite models and pipelines, and the other is kind of, cases where you have to kind of, where you have contradictory things happening inside, how you can kind of tease those apart to understand.
Yeah, that's a very good point, and I think that is that's great to have as a potential collaboration point. So we haven't actually done such a case study yet, where we would look into the contradictory evidence interpretations, but that would be a very interesting case study to do. So I do think that we can use all the tools that we have in Captum and other toolboxes to dig deeper into it. But yeah, that's a great point. I don't think we have done that. So Carla, do you want to add something?
No, I mean, I think those are the right points. I mean, I think that in certain cases we're able to kind of stitch things together in specific ways and kind of gain kind of a more kind of global interpretation of what's happening. But yeah, I mean, again, this is an area that we're actively working in.
Great answers. So back to Aalok. Maybe you could say some things that you're thinking about in terms of research directions for these complex ML ecosystem problems.
Yeah. So yeah, one area we've been looking at is the possibility of learning to explain. So simply what it means is, let's say you have a very complex system. Let's say for fraud detection, you have a bunch of human rules. You have different models which there's a model which takes in text data and gives out an embedding. There's some other data that's coming in tabular data. Just imagine there are multiple models that plug in and out of the system in many ways. And there are if statements, like I said, there is maybe at the end, there is another linear head which takes all these inputs from these models and the human rules and makes a final decision. So you could have any arbitrarily complex system. And to be honest, I think that's more than what we're seeing. Like in production, a model is not one pickled object, or it's more a system of models and code, which comes together to take in an input and finally give a result. So in that sense, how do you understand such a system, right? Do you understand each model by parts? Yes, that could help, but how do you like tally together everything? Like how do you weave it all together? So one direction we feel is promising is, and I mean, this has been done before, but hasn't been formalized in terms of research, as in how do you ensure that it is faithful to the original system? So basically the idea is you take the inputs and you learn this whole system, not just its individual parts, but the system as a whole. You get an inputs and you get an output. But the trick here is, it sounds simple in theory, but you have to give some guarantees, right? It has to be, well, sufficiently accurate in all localities of the data manifold. It cannot be very accurate in some, less accurate in others. And also you run into this issue of, well, if it's such a complex system, then mimicking it will also take a pretty strong, like a pretty large model. So what is the best we can do in terms of the surrogate model size and accuracy and fidelity to the original model's thinking? So yeah, that I feel is a very interesting direction to explain these kinds of systems. Of course, there will always be a faithfulness trade-off, but in terms of what is useful and what can be a first step, I think this could be a good first step.
It's really super. I'm excited about all this stuff. I think we've pretty much exhausted our time here. So I'd like to thank all of you guys for participating. Like, I think this partnership is super fun. I'm looking forward to spending some more time with Captum myself. I spend plenty of time with Fiddler. But Carlos, Narina, Aalok, thank you guys very much. And I think that's it for us.